Okay, here's our first example of a related rates problem after we've gone through the ideas. We have an airplane that's flying on a horizontal flight path that will take it directly over a radar tracking station. If the distance from the plane to the station, it says plan. That should say plane. To the station is decreasing at a rate of 400 meters, not meters, miles per hour when s equals 10. What is the speed of the plane? This one was supposed to come with a picture. So let me include the picture for you. Okay. Because you're like, what is S? So here's the station, right? And I'm terrible at drawing, so that's my plane. Okay. But if I drew the plane, it'd be facing that way, just so you know. Okay. So the plane's going that way. And then the rest of the diagram includes this triangle. This is labeled S, this is labeled X, and this is labeled 6. Okay. So we were given the picture in this one. We're not always given the picture, but we start with this one and we have the picture. So let's go back and reread. The airplane is flying on a horizontal flight path. So if it's facing this way, it's flying this way. Horizontal means it's staying at the same vertical distance. And it's going to end up going right over this station. If the distance from the plane to the station, so that would be this distance, is decreasing at a rate of 400 miles per hour when S is 10, what is the speed of the plane? Okay, so let's start with what do we know? And then we're going to try to figure out what do we want? What do we know? We know that the distance from the plane to the station, which is this one here, is decreasing at a rate of 400 miles per hour. So we know that ds dt is negative 400 because it's getting smaller at that rate. Okay. And this is a moment, we usually add the moment to the want section. Okay. So we know we want something at the moment when S is 10. What are we looking for? The speed of the plane. If the plane's going this way, right, is there anything in this triangle that can relate to how fast the plane is going this way? Isn't that basically the same? If the plane goes this way, right, this whole side of the triangle is going to come with it. This whole triangle, I wish I had a nice animation here. So it's really the same as how X is changing, right? X is going to get smaller at the same rate that the plane is going this way. So what we're really looking for is dx dt. If we're being totally honest, we want the absolute value of that because we want speed, right? So I imagine dx dt is going to be negative because x is getting smaller, but the speed of the plane will be the positive version of that. Okay. So if it helps, take a minute and press pause and convince yourself that what we just wrote down lines up with the information in the problem. This is the critical step, is making sure you can make sense of each part of this. So once we accept that, then we're looking for an equation that relates my S and my X in this scenario. Well, I have a right triangle, and I know that this side is going to be constant the whole time because the plane's vertical distance is not changing. So this side was labeled 6, it's always going to be 6. So it seems to me we could use the Pythagorean theorem to relate X and S. So then we'll take the derivative of both sides with respect to t. Derivative of 6 squared is 0. My 2's will cancel. And then I'm going to plug in what I know. So let's see. I don't know dx dt. I'm looking for that. Oh, do I know x? I should be able to figure it out because if S is 10 and this side is always 6, what's the X at that moment? Little Pythagorean theorem will tell you it's 8, right? So this is my moment triangle. And so I'm going to fill that in. And a quick calculation will show me that dx dt is negative 500, but if I do the absolute value of that, it will be 500. And so my plane is moving at 500 miles per hour.